Welcome to all to the next videos of about iron carbon phase diagram. Previously in the two videos we have seen a better glimpse about first about the major phases, temperature, and the different type and differentiating steel and cast iron with the percentage of weight percentage of carbon, and major phases like liquid, austenite, ferrite, delta ferrite, cementite, and then we have seen about the temperatures. Then we have seen the different invariant reactions that occurs at the iron carbon phase diagram, right? Now we are going to see when we combine all the glimpses what we have seen in the last two videos. When we put together, we see a full iron carbon diagram as we see like this. Then we have some more points to be discussed. The first thing is that before going to that point, I have to say the thing which is normally we have seen in physics. It is simple cubic where we have 8 number of atoms at the 8 corners. Body centered cubic, 8 atoms at the 8 corners and a single atom at the center, and 8 atoms at the 8 corner, or each atoms at the faces, and that forms the face centered cubic, which is a closely packed one. So these are nothing but the crystal structures. Then when we see the single phases in elaborate, first one is ferrite. So here the ferrite, it's a pure form of iron at room temperature. Means that this alpha ferrite happens or looks at the temperature or looks at the carbon percentage is around 0.002. Means this is completed a purest form. Okay, it has carbon percentage only up to 0.025, and it occurs from the room temperature to a temperature around 700 degrees Celsius. So it's a alpha ferrite, it's a pure form of iron. So the microstructure which I have shown here, you can see this white are ferrite and this black dots, so something around we can say it is we can say it is we can say it is a small carbon pieces, small carbon carbon atoms. Okay, so this full thing is ferrite. Maybe this we can consider as carbon, right? So the next one is body centered cube. So it's a body centered cubic crystal structure, as we see in this body centered cubic at the previous slide. And next to that, it is as I already said, it has less than 0.01% of carbon that can be dissolved in ferrite at room temperature, and it is very soft and ductile, which because of this this is due to the less percentage of carbon. This is due to less percentage of carbon. Okay. Then apart from it, we have another ferrite is known as D ferrite. It is known as delta ferrite. Okay, so delta ferrite. So this delta ferrite is a twin of alpha ferrite. The only one thing what you have to note it down is that this delta ferrite occurs at higher temperature, this alpha ferrite occurs at the lower temperature, but other than that, both the ferrites has the same properties. So here it is this ferrite steel has undergone extensively for cold working. Now when we comes into the next thing, which is known as martensite. So here when martensite comes into the picture, it is an interstitial solid solution. Means that this austenite when we see in the iron carbon, only this austenite has the 0.2% of carbon, 2 weight percentage of carbon. So when we compare with the other major phases, you can say this iron carbon, this austenite will have the bigger loop, so it accumulates more number of iron and carbon atoms. So it has the so it is a phase centered cubic and has a maximum solubility of 2% up to 2% of carbon in it, and it is much softer than ferrite. And this austenite is soft, tough, and highly ductile. So this is due to another process, which I will discuss it later. It is not stable at room temperature. Means that we can see the austenite loop starts from around 700 degrees Celsius and goes up to 1130. It is around 1400. Okay, 1200 or 1400. So this variation, you can see it is not available at room temperature, but using some of these austenite stabilizers you can make this austenite to make it available in the room temperature. So with this austenite only, we are having some austenitic stainless steel like 304 stainless steel, 316 stainless steel. The 3 series stainless steel are nothing but the austenitic stainless steel. So this all happens due to the stabilizers what you're using it. Okay, that's all for today. We'll see the rest of the phases elaborately in the forthcoming videos. Thank you.